Hi everybody, welcome to Unit 3 Video 1. This is an introduction to quadratic functions. We're going to start here with our basic quadratic function, that is f of x equals x squared. Quadratic indicates that the highest exponent we have is a 2. So this is a parent function, f of x equals x squared. No transformations have been made to that. We're going to save that for our next slide. With this, I have to consider the domain. My domain is all my input values, all of the x's. So the question I ask is, what numbers are you not allowed to square? What numbers would you mathematically not be allowed to multiply by themselves? And a funny question, but if you keep that in mind as whenever we talk about domain with all of the functions that you'll come across, it'll really give you a good perspective on what domain really is asking. Is there something you're not allowed to do that operation on? I can square positives, I can square negatives, and I can square 0. So what am I limited to not squaring? I don't have any limitations, and therefore my domain is all real numbers. My range is the output. So if I'm allowed to square positives, my output is a positive number. And if I square 0, my output is 0. And if I square a negative, my output is it's positive. So when you determine your range, you consider if I'm allowed to put in any number I want, what restrictions are on the numbers that will be my output values. And here my range, my output is limited to numbers that are greater than or equal to 0. And that is because anytime I square a negative number, my output is still 0, or still positive. The smallest number I'll get is when I square 0. So my range in this on the parent function of f of x equals x squared is 0 to infinity. My axis of symmetry, we're going to discuss that after we get a little bit more on our graph. So I'm going to start by making a table of values. And I'm going to make just a normal setup here. We'll see what happens. This is what we often use when we start with a parent function, is just the typical 5 points. And let's start squaring these numbers. So negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. Oh, and I do see a pattern. I see a pattern that looks kind of similar to our pattern that we had with absolute value. And it does share similarities. It shares this symmetry across what we call the vertex. So this value 0, 0, that ordered pair, is the vertex. It's the stem of where our symmetry will begin. The axis of symmetry is a line that goes through the vertex that creates that mirror image on either side. It's x equals 0. Your axis of symmetry is the equation of a vertical line, so it must be written in the form x equals 0. Let's go ahead and plot these points, and then we'll discuss our maximum and minimum. So I have 0, 0, and then I start to see this symmetry created right there. This is not a V. If it were a V, it would have the same slope, if you will, between each point. And it doesn't. It has a 1 over 1 here, and the next step is a 3 over 1. We're going to discuss more of that pattern in class. So the picture that we actually get is a U-shaped picture. It's not a V, it's a U, and it's called a parabola. A parabola. So my minimum value is either the highest or lowest value on the graph. And when I speak of high and low, I'm speaking of our y values. So this is always in reference to a y value. And my minimum in this case, because there is no highest point, it does go up to infinity forever. So my minimum value is y equals 0. It's the lowest place on the graph. Let's go ahead and apply some transformations to our parent function. This is the parent function written in vertex form. So similar to how we had the absolute value, these values are actually changed the same way. The equation is altered, the graph is altered. So the a value here actually is a stretch or compression. A vertical stretch. And I can't say that it affects the slope because the slope would be our constant rate of change, as it was with the absolute value. And this is this change is not going to be as constant. It's not constant at all as the last one, so as our absolute value. So in that case, we're not going to call it a slope change, but it is a stretch or a compression vertically on our function. The h value here is showing us our translation horizontally. And, oops, we'll move that arrow. And the k is our translation vertically. So let me go ahead and give you an example. Let's start with y equals the quantity of x minus 3 squared plus 1. I'm going to first start by identifying my vertex. And my vertex, just as we did with the absolute value functions, is the opposite of what was hiding in there with x in the parentheses, and the same as what was on the outside. So this vertex moved from the origin at 0, 0 to the right 3 and up 1. And let's make that our transformation list. It went right 3 and up 1. Okay, so if I have my vertex, the first thing I'm going to do with it is put it into my table of values. I'm going to choose two values that are higher than or greater than 3 and two values that are less than 3. Because this is my vertex, I know that there's going to be symmetry around that vertex. So that makes my axis of symmetry at x equals 3. So if I were to start squaring these numbers, or plugging them into my formula here, 5 minus 3 squared is 2. Squared is 4 plus 1, so it's 5. Because of the symmetry, I know that if I were to substitute in 1, I would get the same answer. Let's substitute in 2. 2 minus 3 is 1, squared is 1, plus 1 makes 2. So this is my beginning of my table of values that I can use to graph. Let's go ahead and plot those points. Okay, so to answer the last couple questions, my domain and range. My domain is going to be any number I want, so it's all real numbers, or from negative infinity to positive infinity. And my range, written in interval notation, says, well, I have to start at the very lowest point for this picture, and it goes on to positive infinity. Well, the smallest outcome value that I will have is going to be a positive 1. And it goes to infinity. Well, that helps me because the last thing I wanted was to know my min or max. And in this case, I have a minimum, and my minimum value is y equals 1. Let's go on to the next. Next example here, let's try, is y equals 2 times the quantity of x plus 4 squared. So for this one, let's again start with our vertex, and that will help us find our transformations. And then we'll answer our axis of symmetry question once we have our table. Then we'll have our domain and range, and lastly our maximum or minimum. Okay, so the vertex on this is going to be the opposite of what's in the parentheses and the same as on the outside. Well, I'm not adding or subtracting anything, which means I don't have a vertical translation at all. So my only translation is that I went left 4. However, something different about this graph is that there is a 2 in front of the quantity that's being squared, and that 2 represents a vertical stretch by 2. A vertical stretch by 2. Okay, so let's go ahead then and start making a table of values. I always put the vertex in the middle. It's a great visual representation so I can create the symmetry. which means that this is going to be my axis of symmetry at x equals -4. I'm going to choose two numbers that are greater than and two numbers that are less than my x value at the vertex. And I know that I will have symmetry over those values. So I'm going to substitute in whichever value I like. I can either use the -6 or the -2. So I'm really only having to do the work for 2 extra values rather than 4. So if I substitute in -2, -2 plus 4 is 2, squared is 4, times 2 is 8. Then if I have -3 plus 4 is 1, squared is 1, times 2 is 2. And these numbers will be repeated on the other side. So I'm noticing here, after I graph it, we'll be able to find our domain, range, and max and min very easily. -4, 0, and then I'm going to plot the other 4 points. And as you can see, this parabola is much skinnier because of that vertical stretch by 2. It rose a lot faster. My domain is always all real numbers. And my range in this case looks like it still begins at 0. My y value is still 0 and goes on to infinity, making this a minimum of y equals 0. Let's try one more. All right, so this is our third example here, and let's throw all sorts of transformations on it. Go ahead and get that copy down. That's f of x equals -2 times the quantity of x minus 1 squared plus 3. Again, we're going to begin with our vertex. And my vertex here is +1, +3. And then I'm going to identify my transformations. And I can notice that I have my obvious ones, my right one and up 3. But my a value is 2. Okay, and please note I said my a value is 2. And so that's my vertical stretch by 2. And I also have a reflection. My a value is never negative. It's a -1 that's being multiplied there as well. We just look at it and call it a -2, but when I'm speaking of transformations, my a value is 2 and there's a reflection. So this is going to have a completely different look than our last couple pictures. Because of the reflection, it's going to open downward. So the third thing we looked at was our axis of symmetry, and then we have our domain and range, and lastly our maximum and minimum. So let's make a table of values for this function. I'm going to start by putting my vertex in the middle as I've always done, and my axis of symmetry will be x equals 1. It goes right through there. And if I choose numbers that are larger than 1 and less than 1, and then I were to choose either side, I'd want to go ahead and substitute numbers in. So I like making my quantities positive, so I'm going to multiply, I'm going to put in the 3 and the 2. Maybe the 0 wouldn't be a bad idea. I avoid the negatives just for avoiding careless mistakes. Number 3, putting in the 3, -1 is 2, squared is 4, times -2 is -8, plus 3 is going to be a -5. And it's also the same up there for the x value of -1. I'm going to plug in the 2. 2 minus 1 is 1, squared is 1, times -2 is -2, plus 3 is 1. So if I plot those points, and connect them, making my parabola or my parabolic shape, I'll notice that this graph opens down, which is what I thought it would do because I saw that there was a reflection. And that does not change my domain. My domain is still all real numbers, but it does change my range because I no longer have a bottom place where I'm looking and then rising up. Here I have a top and I'm looking down. But when we do our range, we always start at the minimum, which is negative infinity, and up to the top, which is a positive 3 inclusive, which means this graph has a maximum value at y equals positive 3. All right. For your homework, we'd like you to try numbers 1 through 4, and you're only going to do parts A through C on those 4 examples, and then 5 through 8 is matching. So go ahead and put those in your notebook, and we'll discuss those in class tomorrow.